Welcome back to McCarthy Performance. Today we'll be taking some pistons off some H-beam rods. We're going to measure everything. It's going to be easier to check the condition of the rods, the small end of the rod with the pistons off. Going to check the pistons for size and if there's any damage. So it's just easier to take everything apart. These are a heavy wall pin. This is for a boosted or power adder application, so they have the thick pins in them. If you have a tool like this, you can usually push them out. They have spiral locks on them. What happens is after a while the pin gets a little bit hammered. The spiral lock groove gets a little bit hammered, I should say, sometimes, not all the time. And you can also get a little bit of a burr when you put the spiral lock in or take it out. So you have to sometimes deburr it, but you're going to need something to push this out. And if you don't have a driver like this, you can make one on a lathe. They're not hard to make, you know, that'll go in there. Or you can take a 3/8, because this is a smaller pin. You can take a 3/8 extension and put a socket on it, a deep well or a short, and you know it'll center itself on the pin so you can tap it out. Of course, you don't want to use anything metal. I usually use a rubber or a brass hammer. You shouldn't have to beat these out. Sometimes they get a little snug because they get a little bit of a burr on them. You can take a tool like this sometimes. It won't come out, and very carefully go around the pin bore of the piston and clean that up a little bit. You don't want to take any material, you know, you got to be careful. You don't want to take too much material out with this. So I've taken these all off, and I have one left, and I'm going to take the spiral lock out, show you how I do them. Sometimes they can be a real bugger. Some pistons put a little bit of a notch in here, and you can put a O-ring tool or a hook in there, and you can pop it up, and then you can take and peel it out with a little screwdriver. These don't have that. And these aren't round wire locks, and round wire locks can be a real trip. Usually getting them out, they usually take off into another time and dimension. So these are just plain spiral locks. These aren't too bad to take out, put in. Some guys like round wire locks, some guys like spiral locks. It don't matter. I've done enough of both. But spiral locks, you have a better chance of getting them out and actually physically having them in your hand when the job's done. I probably got about 3 or 4 spiral locks stuck up into the ceiling of the shop, because when they come out with a lot of energy on them, and you really should wear safety glasses, because you could injure your eye with a round wire lock. Spiral locks aren't too bad. So I'm going to set up over here, and I'll show you how I take out a spiral lock. And the mill's going in the background, cutting the 565 deck. Okay, it's really nice if you've got a rod vise. If you don't have a rod vise, you could probably clamp the rod to a side of a table with a piece of wood and use a clamp and clamp down on the big end of the rod. The sturdier you have this so it doesn't move around, the better off you are. Usually on the spiral lock, there'll be a little bit of a a hook on it. It'll be cut out like that, and you can usually slide a small screwdriver. That I've got different screwdrivers that have been modified, and it's kind of hard to say what would work the best because everybody's probably got their own special tool. But these are some tools that I've had over the years that I've just kind of modified. Obviously, this is basically just a hook, and this one was a O-ring tool that broke off, and it's got a little notch on the end of it there. And then this is a screwdriver that's just been filed down to almost like a blade. So we want to stick the screwdriver tool, if you will, alongside the lock, and we want to hook it, and we want the piston to rotate. You want to make sure that when you're prying on it that the piston's not going to move. So if you hook it like that, you'll get it up a little bit, and then you just pull it out like that, and then you can I run the screwdriver around it and just take it right out. Now this is like a double or a triple lock, some people call them. This is only has one spiral lock, but it's wound 3 times. Some of them are only wound twice and they'll take 2. So this piston design only takes 1. Okay, now if you see there's a burr on the piston right there, but it's not bad. I can shove it up with my thumb, and you know, usually when you take these apart, sometimes I'll have to touch up the pin bores just a little bit because the receiver groove gets kind of chewed up. If you don't have to, you know, murder these things getting them out, usually you don't put any raised edges on them, but they also, just by the sheer nature of them, sometimes just the pin moving around a little bit, you know, kind of hammering it back and forth in there, will put a high spot on these. But it's not a big issue. It's just something that happens. It's kind of normal. If you're real careful, you lessen the chances of that happening. So that's pretty much it. There's not a lot there. Of course, we'll be measuring the pin fit on these and checking everything and make sure that they're not tore up. And these look rather nice. So the next thing we're going to do is we'll check the big end for size to make sure that the rod isn't distorted. And then once we get to that, then we'll check the piston to wall. This is supposed to be pretty much a rebuild, a freshen up. So we're going to check the pistons for any signs of cracking, any distress, looking at the pins, looking at the bushings and the rods. Everything visually looks good so far. We'll probably clean this up, and I'll do a dye penetrant check on here to make sure there's no cracks here. And then if we've got good piston to wall clearance, it'll probably just get a light hone, and there's a chance we might reuse these pistons. Okay, so we got the rods apart. We're cleaning them up as we go here, and then I'm checking them. I'll show you how I check them. But bring this up here. Don't do this. They really don't want you to stamp on these rods. You know, it could cause stress risers. I know that's kind of getting nitpicky, but a lot of rod manufacturers prefer that you don't stamp them. And what I do is I take a Dremel with a little stone and I grind the numbers in there. That way they don't leave any stress risers, or, you know, if you hit it hard enough, it's not really thick right there. You could affect the thread engagement and how the threading function works in the rods, so it's really not a good idea to do that. On stock rods, it's not so much of an issue because usually they're through bolted, but there's not a lot of material here, and could you disrupt the thread engagement somehow by stamping them? Most of the companies just don't want you to do it. It's a good idea not to do it. So if you've got aftermarket rods, you don't really necessarily have to number the rods. If you don't want to, you can number the pistons, although, you know, if everything is the same within a couple tenths, you can put it all together. You know, for later checking things, you know, you can take a paint marker and mark them if you want. Usually from the factory, they'll have a series of numbers, so you really can't mix up the caps unless you sand on them like they did, and then there's no numbers, and then you have to put something here to identify the caps. You know, you won't get a 1, 2, 3 to 8 firing order on a set of 8 aftermarket rods, but they'll have a series of numbers, and usually that's thumbprint for the cap, so you can't mix them up. We have the rods all cleaned up, broke the edge on the parting line, washed everything, re-lubed them, torqued them up. We're going to check them for size. Where the gauge is set at the small end of the housing bore spec. We're going to see where they are. Okay, so we're 2/10 over the small end of the spec. At the parting lines, we go up to, we'll call it a half. So that'd be 5/10. So that's like 3/10 out of round. This one's pretty much the same. This one's pretty much the same. So I might clean them up a little bit. We're going to put the bearing back in the rod. We're going to see what they were running for oil clearance. You didn't get a piece of paper, any paperwork on this engine for oil clearances. It's been run. So what that's going to allow me to do is look at his bearings and determine whether or not I want to go tighter on the bearing or looser on the oil clearance for the bearing. And these rods had a standard and a 1. So they X, they were trying to get more clearance from what I can gather, but we don't know what the clearance was. But looking at the bearing for the power level, it looks like they could have been a little looser. So we're going to see where they are. And instead of going to a 1X, half of a 1X, I might go to a full 1X. And I'll just tune these in just a little tiny bit. I will take a little bit off the cap and possibly lightly hone them. That'll put me at the small end of the housing bore, which that's where I'd like to be. The tune-up doesn't look like it was too far off. There's no sign of fretting or moving around the bearings or detonation on the bearing. So I'd like to draw them up a little bit and then maybe just go to a full 1X. But so the housing bores appear to be good. We're going to check them for straightness. We'll do that here shortly. And then after we check them for straightness, we're probably going to just set the rods off to the side and tell the customer where we are. I will put a bearing in it, and I'll check his oil clearance on his crankshaft. the engine was running. It's just probably a need of a light polish on the crank. We're going to be taking a lot of material off, so we're not going to change the clearance too much. But I kind of want to know what clearances they were running on this engine before I just rebuild it and just slap some bearings in it. Of course, we'll be checking clearances before and after and during. So this is going to take a little more time than, you know, just a normal straight through build. But I'll have an idea because I know what power level this engine was supposed to be run at. I'll know basically what clearances they had. And then I know what clearances I usually like to put in them. And then when we assemble it, we'll check, of course, all the clearances. So we'll know what we have after the fact as well. So that's what we're going to do. And we'll continue with checking these rods. So far, they don't, if these rods are further out of round, I would probably suggest to the customer to buy a better rod. This engine's going to see a lot of street use. It's not going to be what it used to be, was pretty much a drag race engine from what I've been told. So that's kind of where we're going with this. So we're checking for twist on the rod. Sighting down it. You want to check this because we don't know if an injector ever hung up or the engine ever hydraulic. You can check the wear on the bearings to check to see if the rod's out of alignment. That looks good, but we're just going through and checking them anyways to make sure that everything is true. So far everything looks good. This is how I do it. Somebody might not like the way I'm doing it. That's fine. That's the way I do it. Cleaned up the pins, made sure they're free of any dirt or any foreign material. And in the fixture, I took that off, cleaned it all up. Good there, looks pretty good. Sighting down it, looking for air gap. If the rod's obviously really bent, you're gonna know. The tool ain't gonna register square to the faceplate, and then relative to the fixture, it won't be true. So, of course, you want to make sure you're setting on your pins squarely. This is kind of dovetailed in here. This is where the pins slide back and forth. Of course, you don't want a bunch of junk in there. be sitting flat. So far so good. So now that we have established that they probably appear to be all straight, I've got 2 more to check and then we'll know for a fact, but then we're going to check and see what we had for oil clearance when it was running, and then I'll determine if I want to adjust that. So when I order the bearings, I have a pretty good idea where I want to be at. I'd say that they're all in good usable shape. So we got number 6 rod, number 6 bearing, measured number 6 journal, going to measure it. We're going to check it for clearance. It looks like about 3 4/10. That's not horrible for a race engine, although this is going to see more street use than race time at the track. So we'll probably put a coated bearing in it. Go with probably a 1X. I'm going to tighten up the housing. 3/10. That's going to put us roughly at 3/1000. So that should be good. So we're going to continue on with this. So far everything looks good. There shouldn't be a problem with anything. Okay, we're all done milling the deck on this side with the BHJ True Deck. You've seen me do this before. Um, so she's at 10,190 right now. That's where she needs to be. I'm going to roll her over. Got her oiled up, everything in the shop this time of year. It's just almost impossible to keep things from taking off and rusting. So I think that's probably going to be it on this video here. We're going to rotate the block, deck this side and square it up. We're going to hone it. I'm still waiting for the lifters. When lifters show up, I'll prep out the block, do a little trimming, put a screen in here. The LS engine, I mic'd all the pistons, I mic'd the cylinder bores. I'm going to take the pistons and we're going to clean them up. We're going to do a not a mag check. We're going to do a penetrant check on them. We can't do a magnetic check on aluminum, obviously. So we'll do a penetrant check on this. We're going to check the tops of the pistons. Then we're going to check the block and the webbing. I'm going to look around and do maybe a penetrant check on some of these areas. And then I'll tell the customer and decide which way he wants to go on this. I guess we're going to wrap this video up here. Thank you for watching.